This one, here I'll crank it up with, see there I got a good charge. Now I lift the wire, and perhaps you can, I think you can see the little white pebbles. Those are the homemade drying agent, anhydride.
Tilt it a little bit more.
That's about as far as you can.
There you go.
Now this instrument depends on gravity, basic properties of electricity, and, as I say, the size of the can and the geometry, the way it's suspended. This gives a tremendous advantage because the calibration has already been done. It was done by repeated testing and with different models until we got it at Oak Ridge National Laboratory. Now, even these expensive instruments, you have to have them calibrated periodically with a radiation source, and not a weak source like the uranium ore. And then, if anything goes wrong, especially at the higher dose rates, you don't know it. Whereas unless the basic laws of physics change, or you take it to the moon, it wouldn't work on the moon for the reason that the gravity forces on the leaves would be different. But just so long as you keep it on this Earth, it's in proper, very simple mechanical adjustment, it's going to be accurate. For that reason, I have expensive instruments, also a very good British instrument, the Plessy Company. It's the standard of both the British Army and British Civil Defense, and is in the $300 or $400 class range. But even you're not sure if it's working or not. Well, any questions come to mind? Oh, a good many people have asked me, what's the pencil doing? And the pencil is there in order to, well, this one's already charged so I can look down on it. So you have, to get the most accurate readings, this instrument is worked out so that with a distance of 12 inches from here to here, you can get a reading that is dependable. You notice here it has a scale, and the instrument is read by noting what the apparent position of the lower edges of first, say, the right leaf, and then of the other. Of course, you're keeping it quiet, not carrying it around. And you add those two readings together. And if you get, say, let's assume this is about, I could read it accurately, but suppose the sum of those two positions of the lower edges of the leaves is, say, 10 on one side and 8 on another, which is 18 of these little divisions. All of this, of course, is in the instructions that you cut out. And if then, most everybody has a watch, but if you're in a severe radiation and you find that after a mere 15 seconds, you read it after 15 seconds, if you see the leaves are just literally going together like that, then if after 15 seconds you read it and you get a reading of 6, then you take that reading from the other, and that would be a difference of 12. And if it had been 15 seconds, that means the dose rate is 37 Roentgens per hour. If that continued and you were out in that dose rate for 10 hours, you'd have about a 50-50 chance of being a dead man. This is, of course, a part of the instructions which you cut out and put on the can, as we'll see later when you and I make an instrument. There's also, after you've finished this, reminders to operators, which remind people what doses are dangerous and how to convert dose to dose rate and vice versa. Well, we're about ready to go, and I'll come around so you can see better. Okay. Well, here we're getting started and actually making it. And we've gone through the information on why you need radiation monitoring instruments and how you read it. And as you see, there are photographs of the same as I showed you of the meter and the dimension drawings. And then there's a list of materials needed. We went through this when we got all these odds and ends together. So now we're ready to split up the work. And a family, one way to save time is have one person, here's a piece of wallboard, as you know, and I'll just show it to you, and then you can hand it over and try your own hand at doing it. You want to cut off the paper, and this has also paint on it, and I'll get it out of sight over here a little bit. And then you got the idea, I'm sure, so just start breaking the pieces off. Try to get them in as square as you can. They won't break square, but you can get them down with your fingers. And what you're going to do is well, you want to just not the dust and all finally, but it's all right in breaking it. And you're going to make a little dish out of the aluminum foil here. This is so you're going to put it in the oven. You could put it right over a fire and then pour it in afterwards. But if you're using an oven, this way you can end up making, which I didn't show you, these are balls of the amount needed. And in order to be sure you get enough of it, after you get through, I won't go through with it, but you put the pieces in there till they cover the bottom. That's the measure of enough to be in the final one, as you see here. Look like little pebbles in there. So if you start doing that, I'll continue with this in just a minute. Here we have an illustration of how first you have to cut out the pattern, which I'll do right now. Here it is. Let's see, let's stick this in. And these are extra pages. These are just repeats of what's in the main part of the book. And so people could make a meter, even if they don't have a copying machine, without destroying the main text. There's 4 extra pages of patterns. So I'll just cut this out. I'll do this right along the lines, and these patterns are made so they go right around. I better put glasses on my old eyes. You see, it's got the essential table that relates the change in readings to the total dose of gamma radiation that caused that change. And this is made to fit around a standard 8-ounce can, as I mentioned earlier today.
Okay, now I have a question.
Now, yes.
Normally we put this in the oven?
No, yes, you put it in the oven, but it ought to be in smaller chunks than that. Here, you can't look at it while I'm doing this, but you see here you have have a look. I really ought to cut this out. I ought to cut this out and give it to you, because if you're working off a different place, a ½ inch by a ½ inch doesn't make much sense. We could put this back together with tape again afterwards, couldn't we? should have zipped this off with my knife. Here, so you can use that as your guide, and don't make them any bigger than that. And you can break off sharp corners with your fingers of this.
Now, how long would we heat them for?
You'd have to heat them for, it's usually best to be safe, for about an hour. If you're heating them in a really red can and it's red hot over a fire, then of course you don't need it that long. But most people have ovens, and this work is done much better before there is a crisis. I've waited for attack several times in 2 wars, and your hands tend to get shaky.
Kind of shaky.
Very shaky. Yeah, the old adrenaline's coming into your blood, and this you can dig a hole better, cut a wood better. But when you're trying to figure out things you've never done before from a written description, and then make these rather delicate hand motions, it gets very difficult.
Hard, yeah. Now these have already been cut.
Those have already been cut,
You want me to fill?
and you see, you put them in a jar afterwards. Then even if the humidity goes up 100%, they literally will last for years in just an ordinary mason jar, in those little balls, you might call them, of aluminum foil around it. So you get the dust out, and then, or just drop in the pieces one by one until you cover the floor or the bottom of the can. Well, here we have this. Throw those out of the way. And what I'm going to do next is wrap this around a can. And you know, we cleaned up a can. It's necessary to clean it thoroughly, get all, especially anything greasy out of it. Clean it good with soap or detergent. We made a couple of little notches here, and that's for the purpose of having the threads where they go over the edge of the can, so they're not in a position that when you're moving the lid around you might disturb them, even if you have them glued or epoxied down. Now we're going to wrap this around, and most any glue will work. Here's about the last of this model airplane general household cement. Now let's see if I can get it even out. It looks like it's, yeah, there's some coming out. So we smear this on here. I've got some more there that would work. We'll put this on first. I'm not going to have enough. I should have gotten some extra. You can use most anything. If necessary, you could just make some flour paste and put it on, because you're going to cover it with film later anyway. This stuff smells like airplane cement. All right. Now, if you'd hold the can, I'll wrap it around. Let's see here. I'll start it at the seam right there. Hold it. And I sure should cut off the rest of it. I'd find out it's made so it'll just go around there. There we go. Be sure you get up. Hold it right there. And we put that on there. American standardization to the rescue, because, as I mentioned earlier, the Chinese cans are the wrong size for this.